8.2, it's going to look really similar to chapter 7 again. We're doing the same thing. We've got two samples and we're finding the difference of two different means, but this time we don't know sigma. So you're going to have a sample standard deviation instead. There's a little bit of new vocab in this section. One is if the variances of the populations, and remember that's the square of the standard deviation. That's this. Okay, that's the variance. If the variance of the populations are equal, so we've got these two samples. If the problem says the variances are equal, that means that the data is pooled. Okay, and what pooled means is we take both all the data from both groups, we put it together to calculate the standard deviation. Okay, not really relevant what's going on there for you, just to know that when the problem says variances of populations are equal, then that means your data is pooled, because your calculator will ask you, is it pooled or not? Okay, if the variances of the populations are not equal, then it's not pooled. Okay, and I'm going to create a little space. I want to put something under here. The other thing that goes with this is if the variances are equal, like they are in this situation here, then the degrees of freedom are n1 plus n2 minus 2. So remember, we need the degrees of freedom because sigma is unknown. And so that means that we're going to do t-test. And remember, the t-curves are a family of curves, and which curve you choose depends on the degrees of freedom, which has always been n minus 1, correct, before now? But that's because we only had one sample. So now what do you do if you have two? Okay, so it depends on if they're pooled together or they're not, how you decide what those degrees of freedom are. So if they are pooled, you're going to take the two sample sizes and you're going to add them up and you're going to subtract 2. Basically, it's n minus 1. And the first one minus 1, the first one minus 1, right? Together, it's the 2 minus 2. So that kind of makes sense. If the variances are not equal and the data is not pooled, then the way that you calculate your degrees of freedom are you're going to take the smaller of n1 minus 1 or n2 minus 1. So it's not pooled, so we can't combine them to get a degrees of freedom. It's unpooled, so we have to look at both degrees of freedom and pick the smaller one. Okay. All right, let's walk through a problem. Here we go. A marine biologist claims that the mean length of mature pink sea perch is different in the fall and the winter. So it looks like we are comparing fall and winter. So I'm going to call the fall 1 and the winter 2. So here we go. We've got fall and we've got winter. We're going to compare the two means. And the claim is that they are different. Different means not equal to. So this is going to be my claim. My complement is equal to, that's going to be my H naught. My HA is going to be the claim. And because it's a not equal, it is a two-tailed test. Okay. Alpha is going to be 0.01. So that means that I've got 0.005 on either end. And if you would like to find a critical value, we are going to do a t-distribution inverse norm, or for my TIs, you're doing inverse t. So that is, we've done that before in chapter 7. I'm going to come up here and I'm going to do stat distribution. I'm doing a t-distribution. My degrees of freedom, this is where this matters, okay? So let's go back over here. the population variances are equal. That means that it's going to be, my data is going to be pooled. And so my degrees of freedom for pooled are going to follow this formula. So I'm going to take my two sample sizes, add them, and subtract 2. So what are my sample sizes? I've got 26 and 31. So I'm going to go degrees of freedom is going to be 26 plus 31 minus 2. 26 plus 31 minus 2 is going to give me 55. Okay, so I'm going to go back here to my calculator and I'm going to enter 55. Okay, TIs are doing the same thing. You're just going into your second distribution. You're going inverse T and entering your degrees of freedom as well. Here's my curve. And my area is going to be 0.005, again, measuring from the left. So I'm going to do my dot inverse on the end and 0.005. This is going to give me a t-value of negative 2.67. That means, because this is symmetric, this is 2.67. So my rejection regions are anything less than the left one, greater than the right one. So my rejection region is going to be any t-value that's less than negative 2.67 or any t-value that's greater than positive 2.67. That's my rejection region. And now we're going to do the test. So here we are, we're going into stat. We're going into tests, and we're going into two sample t-test. All right, so here's your little, first of all, stats data. Okay, if you have data, enter the data and click that. We have stats. And here's the thing that you check that's for pooled or not pooled. So we are pooled, so I'm going to check that. And then I'm going to collect this data. I need my sample, standard deviation, and sample size for the first one. So mean standard deviation size. See if I can remember that. Mean sample standard deviation of 14 and size of 26. So 127, 14, 26. Okay, and now I'm going to do my second sample, mean standard deviation sample size. So mean standard deviation sample size. So 117, 931. 117, 931. All right. We are a two-tailed test. My p-value is 0.002. P equals 0.002. Now that value is also divided into, so I'm going to say this is going to be a p-value of 0.001 on both sides. Now that's smaller, so I'm going to draw it as a smaller little wedge. Okay. And that, and if you want to compare your standardized test statistic, it's 3.26. So it is obviously 3.26, way higher than 2.67. So either way you compare, you are going to reject H naught. And before we do the conclusion, I'm going to jump to my TI. So you are going into stat. You're going over to test. And mine is the fourth option, says two sample t-test. And when you click on that, it gives you your long list, and make sure you scroll down to see the whole list of things that you're going to enter: X bar 1, SX1, N1, right? All the way down. At the bottom, you're going to choose your p-value, choose your not equal to thing. And then at the very bottom, it says pooled. And you're going to say no or yes. Make sure you hit enter to highlight your yes before you continue. And that should kick out your info for you. Okay, so pretty straightforward. Whoops. Guess I'm here. And so let's talk about this. We've got our claim is HA. We're going to reject the opposite. So that means that there's going to be enough evidence to support our claim. Where's our chart? Here. Our claim is HA. We're rejecting H naught. There is enough evidence to support the claim. Is enough evidence to support the claim. The end. And that's it, my friends. See you next time.